Okay, I suppose we'll get going because I have good news. It's going to be short because I'm basically just doing some examples of what the quiz is going to be like, and then I will give you the quiz, and it'll be like the examples we do. And I don't have any announcements. Quiz is going to be due on Saturday, just like the last one. And then next week's quiz will also be due on Saturday. And after that is when it's going to get weird because then we miss a Monday, right? So then, I only cover 2/3 of the stuff I'd want on the Wednesday, and then it's like I'm not gonna make a quiz due on, it have to be. We'll do the quiz on the Monday, and then I don't know. I'll probably still make it due on Saturday because it's just like whatever. You miss a Saturday. Darn shucks. Saturday without homework for me. Oh man, that's really a bummer, isn't it? But we'll play it by ear. So anyway, I have to add the upload thing to Blackboard. I'll do that when I'm done class tonight. So expect to see it tonight. But if you just finish in here, that's fine too. You just hand it in. So I think that's all. So last class, we started with a discussion of what I'm calling algebra rules for logical operators. It's technically called Boolean algebra. It is a thing. It's this big list that I was like, hey, you don't have to write this down, but if you want, you can. The reason I said don't write it down is not because you don't need it for like the exercises we're going to work on. It's just it's a lot of writing, and you just need to reference this. Like there's the list. So you could also just pull this up and reference it when you're working on the exercises, and it's the same. But I did write it all on the board. There's a couple of extras in here that I didn't end up writing on the board, but I don't think I've assigned any exercises that need them. But if I did, it's still just like they all work kind of the same, right? It's just, do you have something on the left or right of this arrow? If so, replace it with the thing on the other side, right? Like that's just all of these. That's all they do. So yeah, we went over a bunch of those. And then I also introduced the idea of quantifiers, which the only reason we need them is, well, there's two reasons. One, they're just kind of there all the time. We just don't write them. Like I mentioned, in a formula, we usually have this quantifier for every choice of x, because if you have a formula and it doesn't work for every choice of x, then that's not a formula anymore, right? That's just a random set of symbols that you wrote down, right? So we assume that it's going to be true for all possible choices of x that make sense, even though we don't write it down. And then I discussed De Morgan's law, which so there's one for these quantifiers, and then there's one for the logical operators. It basically just tells you how negation sort of multiplies in, right? It makes, the P and Q not P and not Q, but it also flips the symbol in the middle. So, this P and Q becomes not P or not Q. Right? So you just have to remember to flip that symbol when you do this. It's a common mistake to just miss that. And then there was also a similar thing for these. It's the same thing. If you've got negation on the outside of it, like not, and then for all P of X, then it just becomes there exists X, not P of X, right? It flips the symbol, just the same. So with that being said, I'm just going to do a couple of examples of using these rules and like applying them, basically just doing the algebra. So the point of this exercise is sort of twofold. One, it's to actually, use the things we discussed, but also using them is it's a different type of algebra, but it's just getting practice with algebra again in a way, right? Using rules and manipulating expressions and that sort of thing. So it's just a good refresher on like manipulating mathematical expressions, right? So examples, and these probably won't take too long. I expect like 20 minutes, half an hour at most, and then you get an hour to goof off or work on the assignment, whichever you choose. So we want to simplify the expression. So I have not P or Q and not Q and P. So on exercises that are, for grades, I would do a little bit more than this. So right here I say simplify the expression, and then I've mentioned previously what was simplify, when do you stop, like what's simple enough, right? Usually for these it's obvious, but in an assessment I will say simplify it to this, right? You know, you have this, here's your goal, do the steps to get there, right? And the reason why I do that is, one, it makes it clear what I want you to do, right? So you're not like just shot in the dark trying to figure it out. And two, sometimes what I ask you to simplify it to is not actually the simplest form in a way. It's just something that gives you a journey to get to an expression that is a little simpler, right? So that's the reasons for it. Okay, so to do this, we just use the laws, right? And generally, when it comes to simplifying these expressions, students will often say, well, what do I do first? And the answer is whatever you feel like, right? Because sometimes there's multiple choices you can make to do first, and they'll get you there in the end, right? So an important thing, like let's say you're working on these sorts of problems with a friend. Your friend did it path A, you did path B, but you both got to the same answer. And then you're like, which one of us is right? My answer would be both of you, probably. Unless one of you made an error and then made another error and they cancel each other out, then I would ding you for it. But like, if you got the same answer from the same start but took a different path, you probably both did it right. So don't stress like doing it differently from someone else. That might still be okay. If you're not sure, then you can be like, Travis, is this valid? And then I'll be like, yes or no. So looking at this, I think when we're talking about simplify, generally speaking, we want to remove things or shrink it down as much as possible when we're talking about expressions like this. So we see here, well, not that one, I guess. So here we have that negation in front of some brackets. Well, we have a rule about that, right? It tells us how to distribute the negation into brackets. So that's a good starting point, right? Let's use that. So the first thing we're going to do is we're going to use De Morgan's laws. Which tells us how to distribute that negative in. Now I'm going to write down the name of the law here. I'm not that picky about you doing that. I just want to explain what I'm doing so that it's not like just a mystery which step I did. You can just actually read which step I did. So we're going to take this. This is what we have, and we're going to apply De Morgan's law, which tells us to distribute this thing in. So this is going to be not Q. This sign flips, and then we get a not P, right? We put negation in front of both of our formulas and then flip the sign. Okay, here we have double negative. So we can simplify that too. And this one here, sometimes people would probably do in their head. That's fine too, right? Because these are going to cancel out, right? Some of these rules are straightforward enough that people will do them in their head. That always comes with the risk, though. If you do it in your head and do it wrong, then I can't tell what you did, right? So tread with caution. But in any case, it becomes Q or not P. Okay, so what we can do next is we can just flip the order of these because these look almost the same. So we're going to flip the P and the not P and the Q. And now this part here is the same as this part here. So this isn't a law or anything like that, but we just think about what this means, right? Yeah, sure, we've got something more complicated here, but if we had P and P, what could we simplify that down to? Yeah, right? Because in this case, P and P. It just depends on what the truth value of P is, right? So we might as well just only write P. This is not a law or anything. It's just we just think about what happens here, right? So then what are we left with? This is this thing and the same thing. And I don't think we can go further than that, right? Because we need a P and we need a Q. So there is a name for this form. I do not remember what it is, but it's like the minimized form that has only one of each formula in it. So we had a P and a Q. This here has only one P and only one Q, and that would be, in some sense, as simple as you can get. You can't go further than that. But this one, there's kind of really only one way to do it, I think, right? Like, you can't really do anything with this. It's like kind of as simple as it gets. You've got this negative outside of the bracket staring you in the face, and you're like, I'm just going to do that. And then you do it, then it just kind of works itself out, right? And that's probably going to be the case with a lot of these. The only one that's a little bit weird is the distributive law. Mostly in the sense of, well, let's just think about it in terms of regular math, right? We have x times y plus z, right? The distributive law tells us we can multiply that in, right? We get x times y plus x times z, right? That makes sense, right? That's that familiar math. So the thing that people often struggle with is going the opposite way, right? So you have x times y plus y times z. Right, so now you're using the distributive law in reverse. We have a y in common here. So it'll be more obvious if we write it like that, right? We've got a y in common there. So we can pull it out. And we've done the distributive property in reverse. So this is the one that usually people get mixed up. And it's especially harder with the logic laws because we're used to using these symbols, right? Multiplication and addition. We're a lot less used to using these symbols, right? So when something like that is staring you in the face and you're like, how do I undo it? How do I go in reverse? It takes some thinking. So okay, let's do another example. And then I'll probably put myself on the spot and I'll just randomly write something down. Usually that works out fine. We'll see what happens. But this one is prepared. Simplify the expression. Q and not P or not R or P. Okay, so we kind of use the same exact idea here, right? We've got really only one thing to start with. Is this the broken one? Right in the middle there, we've got this negation sign, right? So that's probably a good starting point, right? We should maybe distribute that in and see what happens. So this is De Morgan's law again. So we've got Q and, so this negation goes in, not P. 4 becomes and. We've got not R. So you could just write R if you want. So this came from also double negation. But if you write down that step, that's also okay. You should just do what you're comfortable with, right? If you don't want to do that in your head, you don't have to. If you want to write down not R and then do it in another step, totally okay. Okay, well, what can we do here? Well, we've got and, so these symbols are the same, and we've got some brackets there, right? Which means we don't need those brackets. So we can go ahead and drop them. So what we actually have is this, right? We've sort of dropped that bracket. Okay, so now we kind of have to use the distributive law, right? So one thing that I see students do here is they would look at this and they would say, okay, well, I've got Q and R and not P, right? We just switch those around, or P, right? And then they'll say, hey, wait a minute. I've got something and a P or P, right? And they're like, that's the absorption law. No, because this is not P, right? And this is P. They have to be the same to use that law, right? So we can't use that here. So this sort of idea, unfortunately, wouldn't work. So what we are unfortunately stuck doing is this symbol here is different from these ones, which means we can use the distributive law. So what this says, of course, is just this P is going to hit every single one of these, right, inside. So we just have to remember which symbol goes inside and which goes outside, right? So we just have to be careful with that. So right now we have an OR on the outside, so that's going to kind of end up inside. So we should get, how do I want to write this? Q or P and not P or P and R or P. Right, from just sort of distributing that in. We just use that law. Okay, so now we look at this and we think, okay, well, what can we do next? This is looking pretty nice, right? Because this is also one of our rules on our sheet, right? This is not P or P. Right? It doesn't have a name or anything like that, but what would this simplify to? Not P or P. Well, true. Yeah, it's true because it can't be P, because if P is true, then not P is false. But if P is false, then not P is true, so we would get true either way. So then that means if P is false, we wouldn't be capturing that. So we want to make sure that we, in some of these cases, we just kind of have to think, what would the truth table look like, right? This is one thing, but we can sort of think, what's the truth table going to look like? Yeah.
I was just noticing, since the value is true and it's next to two ands, it could almost be completely.
That's essentially what we're going to do. Yep. So what we're going to say here, this rule is not P or P is the same thing as just writing true, right? But then that means we're going to have Q or P and just true and R or P, but anything and true is just the other thing, right? Because the true doesn't affect it, right? So like think of this. If you have P and T, then if P is false, then this statement is false. If P is true, then this statement is true. So it just depends on the value of P, right? So that means this thing, if we think about it logically, is the same thing as just P. So that essentially means that if we have T and anything, we could just drop the T, right? It just doesn't affect our statement. So T and anything is, well, I'm going to write it like this, because anything is not a nice descriptive word. I'll write it like I wrote it up there, right? P and a true statement or a tautology is just P. So that essentially means we can just drop this T. Aha. We're almost there. So this is what I was talking about right here with the distributive law in reverse. Most students would stop here. At this point, like let's say I just said simplify this. I didn't say get to a specific point. I'd be like, this is like pretty much done, right? If everyone did the next step, and you didn't, I might take off 0.5. So like, well, unfortunately, everyone else got it. But that usually doesn't happen. Most people will stop here, and I'd be like, you're gonna get 5 out of 5 because that's as far as everyone got, right? Yeah.
Complete coincidence that I noticed this. I'm definitely not taking credit for it because I think any other day I wouldn't have. But just specifically, I was thinking about it in my head. I wasn't even running over the rules. I was just thinking about it. That's why I'm saying it's coincidence. But yeah, Q or P and R or P. P doesn't need to be in either of those brackets because if P is true, the whole statement is equal to P. But not really. So should be P for Q and R.
Yeah. Yeah, because well, essentially we're going to use the distributive law in reverse. So yeah, we've got this P right here, right? And let's just think. What does the distributive law say? Well, if we look at it from the other side, we're used to seeing it like this. So it would be Q, and I'm trying to make sure I write it down the same way here. Q and R or P. We would look at this and say, okay, we distribute this in, right? That's something we're used to doing. So we would say, okay, this is Q or P and R or P. But then, hey, wait a minute. That second part is exactly what we have there. It means we can go the other way, right? We have this, but these two things are the same as each other. So we can write this down instead. So this is the distributive law, but in reverse. It's not even really technically correct to call it in reverse because there's no specific direction about the distributive law. It's just we're used to using it to distribute, but we can undistribute as well. The law just says both of them are the same. So the point is this is Q and R or P. And just like this example, there's one P and one Q. So we can't really simplify that any further. There is one P, one Q, and one R. Any further simpler would remove one of those, and then now we don't even have the same statement anymore, right? It depends on P, Q, and R, right? So we can see that this thing here pretty ugly, but this thing here pretty simple. So this is another one of those things where, especially if it's been a really long time since you've done math or algebra in general, what I just did probably looks like arcane wizardry. But when you do it a couple times yourself, it ends up not being that bad, right? You just get some practice with it, and then it's not so bad. So that's kind of, yeah, go ahead.
Could you go over the step for the teacher?
This one right here.
Yeah.
So how did I go from here to here?
Yeah.
Okay, so this, I essentially, that's a fair point. I sort of did this because we know this is true for numbers, so I kind of took it for granted. But I can break it down into multiple steps. So for numbers, if we had like x times, I need more letters, r plus s plus t, right? So we've got 3 letters there. We can distribute this x into all 3, and this would be x times r plus x times s plus x times t, right? So I'm essentially doing that here for the logic rules, but technically, and in general algebra, this is also not a rule. We only have the regular distributive law. So what's really going on here? I can show you. So we're going to write this down here. Q and not P and R, or P. So what we actually have to do is we have to use this distributive law twice. So we have the associative law, which tells us we can put brackets wherever we want in this. So let's just put them here, right? So earlier I removed them, but let's put them back for the purposes of this. So now what we can do is we can use the distributive law. So now we essentially have two pieces here, right? We have this one, which sure, it's more complicated, but then we have this other one, right? This now says we can use the distributive law, right? This is input one, let's call it, I'm just going to use different letters here, right, in terms of our regular symbols, right? So now we only have 3. So what we're going to get is Q or P, just like this. And now this is less nice looking. We've got my blue brackets, which come along for the ride. Or P, right? So that's just, this thing goes into this group here and then that Q. But now we ignore this and we say, oh, we can use the distributive law again, right? We've got something, and then outside of the brackets, or P, right? So we can just distribute again. So we're going to get Q or P, and now we distribute this. So we're going to essentially drop the blue brackets, not P or P, and R or P. But now this is what we have written here. It's the same as this. So this is a good exercise because we often do things like this, and there's something extra going on in the background mechanically that we sort of hide or don't write down. A perfect example of this in math is when you've got an equation and someone says, move it to the other side. That's not actually what we do. We do not move things. So what I mean is, let's say you had x squared plus 2 equals 5x plus 2, right? This is just an equation, right? So it's common for people to say, move this to the other side. We don't do that. What we actually do is we subtract something from both sides. So what we do is we say, okay, I'm going to take this, and I'm going to subtract 5x and 2 from both sides of an equation. Because what we can do to any equation that we have written down, we can do anything we want to it as long as we do it to both sides, right? Okay, but what happens when we do that? Minus 5x cancels with that, 2 cancels with that, and we've got x squared plus 2, these minus 2's cancel out. So it's going to be x squared minus 5x equals 0. Now, the high school algebra that you would have known is move that over, right? And you get this, right? Move the 2 over, they cancel out. Move the 5 over, you get minus 5x on that side. But the point I'm making here is there's something else actually going on in the background, sort of like this, right? I distributed this, and it looks like it's one rule, but actually it's 2 rules in disguise. This looks like it's some, like, you just move stuff over. But no, it's the hard rule of you can do anything you want to an equation as long as you do it to both sides, right? You can add stuff, you can subtract stuff, you can multiply by stuff, as long as it's not 0. Okay. So, do you want me to do another one, or do you want me to set you free? One more? Okay. So this one, I have to warn you, I do not have a third one prepared. So what that means is I'm going to write one down, which historically works out fine. But there's like a 10% chance that I write down something that is kind of a hard one. Sorry, yeah, question?
So when we're doing that for the quiz, do you want us to write down what we're doing? Like,
Okay, so
they'll know.
if it's obvious, no, you don't have to worry. Like if you only did one thing, then I mean, I can tell what you did, generally speaking. Like this is for me explaining which thing I'm doing. And on my quiz template, I think it still says write down what you do. You don't have to do that. I need to change the template because my template is basically it says simplify the expression and then it's a blank and then I fill in the blank with whatever I came up with. But I just haven't updated the template, so no, you don't have to write all this. Okay, so simplify the expression. All right, let's work together. Give me a letter, P, Q, or R. Okay, give me an operation. Okay, let's do not Q. Actually, I'm going to do this. Not Q or R or P and R. I don't know. We'll see what happens. I mean, this might simplify down to like P, right? I don't know. I didn't construct this example to be interesting. It's just one to practice. Okay, so we're in this position again. I got where we have that negative in front of some brackets, right? So that's always a good first step, right? Let's distribute that in. Let's see what happens when we simplify that. So that again is De Morgan. So this is going to become R and not Q and not R. Okay, great. Well, this one's actually going to be, unfortunately, very straightforward. So now, or maybe I'm just looking at it. You know, yeah, let's work together. What should I maybe try next? So you know what? Let me do this. I'm gonna swap some stuff around using commutative law, and then maybe it'll stand out more. So how about this? So we've got R and not Q, or P and R. Does anything jump out there as something that could be reduced?
R and not R.
Yeah, right. R and not R. This Q doesn't even matter, right? R and not R is false. Yeah, it's always false because one of these is true. When one of these is true, the other is false. So we'll always get false. R and not R is the same thing as false. Okay, cool. So this is going to be false and not Q, or P and R. Okay, so this one right here is a bit more complicated. Well, no, it isn't. It's very not complicated, actually. This was always false, right? It doesn't matter what Q is. We have false and something else, right? So either Q is true, in which case this is still false, or Q is false, and this is false. So F and not Q is the same thing as false. So this whole thing becomes false, or P and R. But false or anything, like false or P. What's that going to be? So think about that. If we have false or something, what does that end up being?
It's true, yeah, it's something.
Yes, it's just P, right? Because two situations to think about. P is true, F or P is true. P is false, F or P is false. So it only depends on P, right? this thing doesn't end up mattering. So this is just P. But the point is it's S or some stuff reduces down to stuff. And now, so this is a good example because we started with a Q. We don't have a Q anymore. What that means is even though this is more like a more complex statement, the truth value of it does not depend on Q at all, right? It doesn't matter what Q is. The only thing we care about is P and R to get our truth values, right? So I didn't hit the 10%. So there are some where if I just write down the perfect collection of things, it'll be like, okay, I distribute in this way, and then I do some simplification, and then I undistribute, and then it's like, wait, I'm back where I started. So then there's like some other obscure trick that you have to do to simplify it. And if I'm giving you one on an assessment, that's not going to happen. But if I just write some random something on the board, it could happen. Yep.
Can you only distribute when you have something or something?
You can do it the other way around. So if you have so let me just make sure I understand what you're saying. So right now we have wait, what are we? You mean like this? Can we distribute that?
Yeah, like would that work if it was P and
Yes. P and Q or R?
Yeah.
Yeah, that also works. So what it would end up being is P and Q or P and R. It's just you basically flip the symbols around and then it still works. So as long as these are different symbols, you're good. Okay, well, I think I will set you free into the wilderness. I will hand out the quiz, which again, it's basically like this, except in this, I have specified, hey, you've got something that looks pretty similar to one of these, and it says, with the goal of reaching something I have written down. So, because I think the one I have written down here, technically, you can take a non-obvious route to get something simpler than what I write down. And just to avoid that, because I don't want you to get lost in the weeds, the quote-unquote obvious path through this one gets you to this form, right? So that's why I wrote it down. Okay.